Okay, so for 4-6, guys, quiet please. Um, so we're just reviewing angles of triangles again because we're going to do a lot of like right triangle geometry today. We're actually going to dive deeper trigonometry in our lessons. So for part A, that's been pretty easy. X is 11 degrees. B, they're both 45. C, 1 is 30, 1 is 60, given the ratios. D, you have 68 left over. So hopefully that was not an issue. Make corrections if you missed any of those. For 4-7, looks like they're similar because corresponding angles are equal. As long as you have two pairs, you're good. So yes, a similarity. Um, examine your work from part A. Are they congruent? Meaning, are they 100% identical? Um, well, they do have a side of 4 each. So I'm pretty sure if you have those two angles and you have a side length that's the same, then it's probably going to be identical triangles. Yeah, the most likely that will be. We'll talk more about that later in the year or in the spring. Yeah.
I'd say no because like
Mhm.
one side could be like the two sides could be
But,
like
but
a little
but look
longer.
where 4 is located though. 4 is located right next to 74 degrees and opposite 9 degrees, right? So clearly AC and FD are in a 1-to-1 ratio. So if that's in a 1-to-1 ratio, you have to maintain. So here's the reason why. What's the ratio between AC and FD and DF? 1-to-1, exactly. So you have to maintain that ratio for all the other pairs of sides. So if all the other pairs of sides are 1-to-1, then all the side lengths are the same. If they're all the same, wouldn't the triangles be identical?
Oh, because since you know they're similar,
You already know the similarity is established.
since you know that they're similar,
Right.
then you know the ratios have to be the same.
Correct. Right. And because the ratio of one pair is already 1-to-1, you got to follow that for all the other pairs. That was great. Actually, great question. Glad you brought that up. Yeah. How would you know, right? You would know because of the ratios. It's 1-to-1 for the sides you do know. And because the triangles are very similar, you got to establish that relationship for everything else, that ratio. So, go ahead. Don't worry about that. Just write it out. It's fine. Yeah. Don't worry about that. Yeah. That was a little weird. I didn't really realize that when I signed the homework. For 4-8, yeah, Pythagorean theorem. You guys should know how that all works out. Just multiply out x plus 1 with x plus 1, set equal to the other side. X squares cancel, fortunately. X is 24. And of course, you can get the perimeter. It's not that hard. So hopefully that was okay. We do want to reinforce off algebra. That's what's happening here, like knowing how to FOIL, combine like terms, solve for x. So that's 4-8. 4-9, these are not triangles, but they're similar shapes. So sides will be proportional. You look at the sides, 12 to 8, x to 6, 6 to y, 10 to z, blah, 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 work it out. Just solving proportions, which is an algebra skill. That's a packet I gave you guys. And by the way, Curie asked a great question about materials, right? Yes, I'll give you a lot of materials. Right now, your main focus is going to be the thick packet I have. And if you have to retake that, all the other stuff, maybe just file it away if you don't want to carry it to school. You don't have to bring it to school every day to answer your question. Maybe if you like a folder or a file cabinet, whatever, file it away, but you will need to refer to it in December though. So don't throw it away. But do you need to bring a class every day? No, don't do that because it's too much to carry. Faith, go ahead. Mm-hmm. That's an interesting question. Yes, go ahead. Mm-hmm.
Seven, like that through the votes.
Hold on a sec. Let me see here. Are each of the outcomes in this table? Oh, I think so. You're overthinking it. Yes, you are correct. The 7 is the most common, right? So if anyone would play like craps or dice, rolling a 7 is the most common. What they meant was each event, this event, this event, this event, this event, this event, this event. So each of these ways you can get a 7. There's 6 ways you can get a 7, right? But each of those 6 ways is equally likely.
Yeah.
So there's 36 possibilities. There's a 1 out of 36 chance you can land any of those squares. It just so happens that the 7 shows up 6 times.
When wouldn't there be like a time?
There wouldn't be, would never. They're all equally, every square is equally likely. It's kind of like if it was a carnival game, you're throwing like a quarter into like a grid. It could fall in any of those squares equally with equal probability.
Oh, so it's just saying like it are all of like this sections equally likely to
Correct.
occur, not the numbers in
No, and that's the wording is kind of messy there. I don't like that. I understand the confusion. Actually, I would probably made the same mistake or being confused the same way. But what's the probability of getting a 2? 1 out of 36. What's probably getting a 7? 1 out of 6. So it's actually kind of a fun thing if we were like to do a mock game of craps. Like, rolling a 7 is actually a good thing in the beginning, and then you don't want to roll a 7 afterwards. And so you play probabilities when or you look at the probabilities when you play those games. The probably getting an even number was 18. Of all the even numbers you can get. So we call this a sample space. And by the way, we are going to talk about geometric probability later in the year. At least I think we are. I'm not 100% sure, but I know that done in the past. There's one way you can get a 2. There's 3 ways you can get a 4. There's 5 ways you can get a 6. There's 5 ways you can get an 8. There's 3 ways you can get a 10, and 1 way you can get a 12. If you add all of it up, all that's going to add up to 18. So there's 18 even numbers. There's 36 outcomes. So 18 out of 36 would be your probably getting an even number. Of getting a 10, there's only 3 ways you can get a 10. You can't get a 15, obviously. That's weird. 7 is most likely, 1 out of 6. But the more I think about Faith, I don't know if I like that answer for part B anymore now. The way it's worded. Are each outcomes in this table equally likely? I actually would say no. Right? To answer your question, I think I would say, because the way it's worded, right? What are we considering to be an outcome? Like that's an outcome, right? That's an outcome. That's an outcome. Is a 7 equally likely as a 2? Absolutely not. Yeah, that's kind of a weird. Let me check with Mr. Davidson about that, like, because he wrote this answer key. I don't really agree with that answer. Don't worry about it for now. It's okay. But it's good, yeah, 7 is not, you don't have an equal chance of getting 7 as you would a 2, right? That wouldn't make any sense. So anyhow, Peter, had a question, Reagan, or no? I thought there was a hand raised. Okay. For 411, see temperature San Antonio is that, blah, blah, blah. Okay, so you start 77 degrees, and it's going up by 3 degrees every hour. So that's why you have to put plus 3h. It's like a linear, what you're doing is you're doing something called linear modeling. Also think about the other one. At Bombay, it's 92 degrees, and it's dropping by 2 degrees per hour. So clearly that's going to be a minus. And of course, they might meet up, their temperatures might meet up somewhere along the way. And, it might make sense because maybe it's noon in Bombay. Sorry, it's noon in San Antonio, but it's like midnight in Bombay. And eventually it's cooling down in India, but heating up in Texas. So I don't know. So it's kind of an interesting question. 418. You guys should know this, ratios. Yeah. So if you're told they're similar, look at the sides. It's a 1-to-4 ratio, 4-to-1, however you want to set it up. The rest should be pretty easy to figure out. So yeah, you got that. 419. You should find missing angles, not a problem, and then prove they're similar. That should be A-okay. C is not enough info. B, the sides are not proportional, so we can't say that. But A was. 420. Use Pythagorean theorem to get the missing sides. You should be able to be okay with that. Kind of review of old stuff. Area, once you have the base and the height, you can find the area. Oh, and this is a good question. Root 27. Do you guys know how to simplify that? Now we talked about it. What 2 numbers multiply 27? Yeah, so you get 3 root 3. How about 72? It's like 36 and 2, right? So you get 6 root 2. But when you add them, unfortunately, you can't combine the root 2 and the root 3. So you just leave it alone, and you have to leave it as a decimal, actually. Yeah, there's really not much else we can do about that. Yeah.
I like left it as like 6 plus 9 plus 3.
Perimeter, oh, sorry. See, you left a 6 plus 9 plus.
Plus 3 plus 6.
That's fine. Yeah, that's okay. Yeah, that's fine. Actually, if I ask for an exact answer, that's exactly what you want to do. So cool. Okay, we're good on that. All right. So let's move on to the notes. So I gave you that thick packet, but we still got to finish those other notes from yesterday. So let's finish those notes first, and then we'll scratch the surface with the big packet. So 4.1 notes, we left it on page 4, I think. That's where we left things last time. We were kind of just doing a little bit on page 4. Then we'll talk about pages 5, 6, and 7. 7, actually, I think we'll skip, actually, because we're not going to do the activity today. But I do want to hit up 5-1 because we are a little behind. So we do have to kind of pick up the slack here a little bit. All right. So let's pick it up from page 3 here. Let me set these up because I think I rushed through this, right? On page 4, top page 4, 437. I think I rushed through it. So let me do 437 with you guys. Then I'll walk around and help you guys at 434. And then we'll do 433 together. And then after that, then we'll kind of talk about just the Statue of Liberty. It's kind of fun. All right. So here, you're going to need a calculator, by the way, for this. You will need a calculator, graphic calculator. I have a few I could lend out. If you so desire, you could probably use your device, not your cell phone, but a laptop. You could use Desmos if you wanted to. But for 437, you're asked to solve for x in each case. Now, remember, we talked about tangent. In case you guys forgot, tangent of an angle equals opposite over hypotenuse. So here I have tangent 38 degrees. What's opposite the 38 degrees? What's right next to 38 degrees? Oh, I'm sorry, I'm sorry. I can't believe I did that. Wow. How did I do that? Oh my gosh. I'm like, sorry about that. I can't believe I did that. That was crazy. I meant to say adjacent, not hypotenuse. That's another thing. Please make that correction. We got distracted with those ways. I apologize. I should know better than that. But I caught myself. See, I made a mistake. I caught myself. I know this stuff. It's opposite over adjacent. Tangent of an angle equals opposite over adjacent. The adjacent is the side next to it, not the hypotenuse. Not the hypotenuse. So please make that correction. My apologies. So that's x over 8. The other one will be tangent 73 degrees. Now, what's opposite 73 degrees? So 9 over x, correct? And lastly, tangent of 45 degrees, x over 14. Very good. Yes. So now what we're going to do is we're going to use a calculator to compute all these. So I do have a TI-84 app here. TI-84. Now, if you use a TI-84 calculator, go to mode and switch that mode to degrees. Yes. Degrees. Go to the third line, hit mode, which is near the top of the calculator, and go down to the third line where it says radian and switch it to degrees. You just hit the right key and hit enter to store it as degrees. To answer your question, Faith, I don't think you need to do it every time, but if you do reset your calculator, yes, you do. Yeah. Or if the battery dies and you have to recharge it, yeah, you have to. Oh, hit enter. Yep. Always enter to select whatever you want. See? No, it's there. It's good now. Yeah, it's there.
Oh,
yeah.
okay.
And then to get out of it, just hit second mode to get out of it. Or clear. That works too. The website? Yeah, it's ti84calc.com. Here, I'll write it up for you right now. It's ti84. ti84 calc.com. Can't be reached. Yeah. Yeah, there you go. Cool. All right, so tangent 38. Tangent's right here. 38, just punch it in. You can close parentheses if you want or not. I don't care. So you get that wacky number, 0.781. So now that I have that, I'll save that sort of in my head. So 0.781 equals x over 8. So how do you solve for x? X will be what? 8 times that number. Sorry, say again, 6.25. Perfect. Good. Okay. You got it. Yeah, good. And it's this math, just so you know, is like not terribly exciting. It's actually pretty boring stuff, but it's easy. It's not hard. It's very easy, actually. 8 times tan 38. Yeah, 6.25. And 2 decimal places works for me, just so you know. Okay, let's do the same thing. Let's switch colors for a bit of contrast. So I'll multiply both sides by x. So don't get so eager to isolate x. Like some people might make mistakes like, oh, let's do 9 times tan 73. But no. X is the denominator, multiply both sides by x. Then what's the next step after that? You do divide by what? You got to do 9 divided by that tangent. So I multiply both sides by x to get x to the left side, but then to truly get x all isolated, x is being multiplied by tan 73, divide by tan 73. If I do that, I should get 2.75. By the way, this is very important. I care about this tremendously. When we solve for x, right? What if you got some weird number? What if you got like, I'm just gonna be hypothetical here. What if it was like 15.86? That makes no sense because if that's 38, wouldn't this be 52 degrees? Which one should be bigger? The side opposite 52 degrees or the side opposite 38 degrees? Yeah, shouldn't the larger angle be opposite the longer side? So if you ever get something that's funky, like weird, like wait one sec, that makes physically no sense, then you probably made a mistake with your algebra or with your setup or something like that. So be mindful about that. Look at the angles that the sides are opposite of. Bigger sides are opposite bigger angles. That would make sense, right? So take a look at like part B. 9 is opposite 73. X is obviously opposite this angle, which is 17 degrees. What if X were bigger than 9? That's strange. X should not be bigger than 9. If X is bigger than 9, you made a mistake. Or what if you got a negative answer? That could happen too. By the way, what's another mistake you could have made in the calculator? What if you didn't switch your mode? What if you're stuck in radians? You can get negative answers. That could happen. And a side length can't be negative, right? You haven't learned about radians. We won't talk about in this class. At least I don't think we do. But be mindful of what physically makes sense for the sides, right? Don't just report them. Well, that's what the calculator told me. Be mindful of what the calculator's telling you. And if you made an error or something else is going on, right? So do A and B make sense? Okay, I'll do C and I'll have you guys try the next one below after that. Okay, for the next one, I'm gonna multiply both sides by 14. Let's switch to maybe a newer color. Let's go pink. So 14 times tan 45 degrees. And if you work it out, what do you get for X? Yeah. So it so happens it's exactly the same as the other side. And why is that? If that's 45, what's left over for the last angle? And if you have two angles are the same, the sides are also the same. So it all makes sense now. We're all seeing why this would make sense. Okay. So you guys are now doing trigonometry. You're now doing trig. So go and try the same process for these below. Yeah. Oh, tangent, just hit tan right here. Right there. Straight up. Yep. Yep. Yeah, Desmos does this as well. If you just type in Desmos, it'll spit out the answer. If you do Desmos, again, you do be mindful about the mode you're in. So if I go to Desmos, and by the way, for SATs, they do ask trigonometry on the SAT. They give you Desmos built into it. Like, so if I want like tangent of 35 degrees, okay, fine, it's saying that. But what mode is it in? There's a monkey wrench off to the right, the settings, and radians is selected. Oh, that's a problem. Switch to degrees. And so now it gives me a different answer. Go ahead. Yeah, opposite over adjacent. So this one here, right? Okay, what angle are you working with? So it all depends. Okay, to truly answer your question, what angle are we working with? That's your reference, right? How is 12 related to 79? That's opposite, yes. So you're going to start by writing the tangent of the angle. The opposite is 12. The W is the adjacent. W is not opposite 79. Now, what if you said, well, I don't want to do 7. I want to do the other one, which is 11. Fine, do it. But then you switch it. Then tan 11 would be W over 12. And it'll still work itself out. It won't matter. If you wanted to use the other angle, 11 degrees. 11 is the leftover angle. Well, what's opposite the 90-degree angle? The hypotenuse. We're not that's not part of the tangent formula. So we don't work with the hypotenuse. We will work with it with other trig functions. We're not going to do that today, though. Well, eventually we will. Here, theta is going to equal 68 degrees. Here, theta is going to equal 72 degrees. And of course, tan 22 is z over 8. And here, tan 18 degrees is x over 15. And I usually use like these little squiggly lines to mean like approximate, because these are going to be decimals. They're not like spot on. Many times you're not going to get exact answers to these. They're going to be decimals because there's just weird numbers. Just to make sure we're getting all the same stuff. Let me work this out. Okay, any questions on these at all? Yeah, Connor, go ahead. 3.24. Okay. Oh, you ran too. Oh, you ran too soon. Oh, that's why. Yeah, you ran a little too soon. I'm just like kind of. Yeah, you got for the first one. Yeah, because you gotta do the W over first, then do the tan 79 over. It's all fractions, right? So if you're trying to solve for the denominator, you gotta know that denominator first, and then divide by tan 79.
Still got 0.
Oh, yeah, reverse it. Let's do 12 over. Yeah, so let's look at the first one, because that's a common error. So I don't want you guys to memorize. So let's take a closer look at A one more time, then we'll move on to the next page. If we look at 434, W times tan of 79 degrees equals 12. Then you do 12 over, not tan over, 12 over. Yeah, you do that. And then you should get W is approximately 2.33. We're okay with that? Okay, let's keep moving. All right, going back to Leaning Tower of Pisa. Write an equation. Okay. So we'll say we'll call the angle slant theta. Oh, by the way, you guys know that's theta, right? The symbol. You guys are familiar with that. I'm not sure if I'm just introducing this new. You guys know what that's called? Theta. It's the Greek alphabet. So theta, that's what we use for angles. Okay, that's a variable we use for angles.
For both the line.
Exactly. Yes. Sorry if I just kind of assumed you guys knew what that meant. I apologize. You can use other letters too, but just a lot of textbooks and mathematicians use Greek alphabets. So Just get used to it. So tangent of theta, because theta is going to be your angle, equals 50/5. Just the angle I'm trying to solve for, the missing angle. So theta, the missing angle is what we'll call theta.
Wait, so in this one, instead of solving for a side, we just have to solve it.
Yeah, exactly, right. So now we need, yes. So the answer is, do you know how to solve this equation yet? No. Because we only have learned how to solve for a side, not an angle. Correct. So your teacher will show you how to solve such equations using a table and a calculator so you can figure out if the tower will topple. Because apparently it'll topple if it's less than 83 degrees, right? Okay. So no, I've not taught you how to do that yet. How do you do that? So you have to isolate beta. Okay. Here's how you do it.
Wait, why is it to the -1?
Great question. This is called inverse tan. To do in the calculator, hit second tan. If you hit second tan in the calculator, it'll give you that function. What it's doing, it's inverting the equation so you can solve for the variable. That's what it's doing. It's inverting the function. You guys haven't learned about inverses yet, so for now you just have to kind of take it for granted. Like, okay, it is what it is. That's what I do. Just do it. So we have to do that. So to show you how it works, I'll clear this for a moment. I'll bring it back. Show how it works. You hit second. So you have to hit the second button. Hit tan. See how it has a little -1 symbol. And you can do just 10 because you already know 55 is 10. If you want to put in 55, go ahead. But I know that's 10. And it gives me the angle, which is 84.28. And that's why the mode matters. Because if I were in radian mode and repeated that feature, it gives you a different number. So very important. You have to be in degree mode. You will miss a lot of questions if you're in the wrong mode. I will help you guys and make sure that doesn't happen to you on a test or final, because that would suck. That'd be horrible. Connor, go ahead. Correct. Yes. Right. So coming back to this again, theta will be 84. Hold on. Click. Oh, yeah. Oh, then we're in trouble. Then we're in trouble. Yep. 84.29 degrees.
Wait, so it's gonna fall.
If it's less, it said. If it's less than 83. Because if it's less than 83, it's leaning too much to the ground. Yeah. So then they would have to then either tear apart the building or put some sort of support systems. I don't know. But it's kind of this architectural marvel, right? So, but has anyone ever been there? No? Oh, okay. No, I've never been to Italy actually. Been to lots of different parts of Europe, not Italy. So, anyhow, okay, all's good there. I don't know, actually, it's a great question. My wife's already been there, so like we went to Spain, we've done Portugal, I've done France, I've done England, done Germany, done Middle East, but I haven't done Italy. Yeah, it's weird. I don't know, just haven't done Italy. Yeah. All right. What other countries? Well, Palestine's not really a country because that'd be considered Israel, but I've been there: Jordan, Egypt, Mexico, Canada, Not that many actually. Trying to think what else. My wife and I love Portugal. That was really Portugal's really fun. Yeah, Portugal's really fun. It was incredible.
What's the
So okay, what's my favorite food? So I'll just say one quick story, and then we'll get going. So we're in Lisbon, and my wife signs us up for this called Culinary Backroads or something. It's like a food tour, and we start at 4 p.m. We don't finish till 1 in the morning. We visit like 6 different places, like 3 different dinners. No, we just like walked around and we took like taxis and like it. And then we went to this one place was really interesting. We go in a warehouse and we're like kind of afraid because like where's this guy taking us? And we're at this other and not to be stereotypical, it was like this Jewish family from New York, very typical Jewish family. The mom is like just very sweet, the dad's like very gruff, kind of like Seinfeld, and like the daughter's like a single woman in her 30s, like very typical Jewish family. And we're like going all over the place just with them and the tour guide. And the tour guide's hilarious. And then we go to this warehouse, and it's actually an Indian restaurant in Portugal.
Oh,
And they made a pork vindaloo dish. Like vindaloo doesn't really use meat, but it was so delicious. It's like the stew. It was one of the best stews I ever had. Oh, it was incredible. Yeah. So Portugal, like 7 or 8 courses. I don't know. No, but different places. So yeah.
I'd be so full.
Yeah, it was pretty odd. Well, you got like samples, but yeah. So anyway, Portugal, go to Portugal. Okay.
That like
Oh, I've been to Morocco. That's another. My wife and I honeymooned in Morocco and Spain. Morocco is a great country too. That's another good food there. A lot of French influence. So anyway,
I think a lot of people go to Italy, like that's like a big
that in
destination.
Greece, yeah, it's like very popular. So Italy's not on the top of my list. So it's I don't know. It's not. I don't find it too
You know, like
interesting. No, I do. Like there's other places I like to see in the world. So I don't know. Yeah.
You should go to Rome and the Amalfi Coast.
Okay. Actually, yeah.
I forgot what it's called. I went to like a really nice like beach town. It was really pretty.
Cool.
Well,
Okay, guys, we gotta get back. This is fun conversation. I can show you. Actually, I can show you photos if we finish in time. Okay, actually, all right. But it was also kind of neat because we did it without like we only had one kid at the time, and we did it with our son, so that was really fun too. So no, we left with my in-laws. No, we went by just me and my wife. Just we left our son here. No. Yes, go ahead. Okay. Let's solve for the missing pieces here. So Z, you guys should know how to do. You should be okay with that. Use a calculator if you need to. Actually, I'll just do it for you guys. So Z should be 13. But in solve for angle Y, you could do this. And you do the inverse tan.
Why is it called?
Tangent?
Yeah, why?
I don't know. Just it's the name we have. I have no idea. Because you do opposite of hypotenuse. Sorry, opposite of adjacent. I don't know why I keep saying that. Opposite over adjacent. Yeah, I don't know why I keep saying
And
hypotenuse.
the tangents, the opposite images is.
Is that what's -1?
The negative one is more of a symbolic thing. That the negative one just means inverse. That's all. It's more of a symbolic than anything else. So I wouldn't really worry about that. Connor, so you had a question or a comment? Correct. Right. Because you're not going to use 90 degrees. And if I punch in my calculator, I should get 22.62 degrees.
Really get a question of this in the past and didn't write any symbol.
You have to round them.
Actually, yeah, you do need to put that because otherwise the assumption would be radians. Yeah, you should. I'm not that much of a stickler with that part, but the degrees, yeah, you kind of need to put that. Hold on, one thing at a time. Zoe had a question first, and Maggie, go ahead.
I forgot.
Okay, great, Maggie, go ahead. Because it's it goes on forever. We don't know what it is. We don't exactly know the true value because it's a bunch of decimals. It's giving, but there's a bunch of other decimals afterwards too. It goes on forever. I don't know where it ends.
So if you're to round, you round for 300 place, right?
Yeah, exactly right. 2 digits.
Like chemistry? Okay.
Correct, right.
boom.
Correct. For X, you want to do 90 degrees minus 22.62 degrees. Because that's what's left over, right? Because if you have 90 already to allocated to the right angle. So if that's 90,
Wait, but that means X is also gonna be approximate because.
correct. Correct. Which would be 67.38 degrees. Yeah, what's up?
X and X equals 12 and 5 is that I did X.
Sure, you could do that too. Same thing. Yeah, if you do tangent X is 12 or 5, that also works too.
Chemistry. One of my friends said that
Mhm.
you
Yes. What,
subbed their class and you made a 6-7 joke. Is that true?
yeah, maybe like actually 3 or 4 different 6 7 lists. Yeah. It came out that way. Yeah. Oh, there we go. I see right there. Okay. I did. And we did for Halloween too.
Your equation for Halloween.
It was a for my pre-calculus class, so you guys might be able to solve it. It was a bunch of like weird shapes, and the intersection point was 6,7. Yeah, 6,7.
Ah.
And it was actually for my test I gave a month ago for my pre-calculus. Yeah, hers, I don't know what hers was. I don't remember.
So it was alternating period.
Well, it's Mr. Davidson.
What did he do? He did geometry one, I'm sure. I don't know. I don't remember. Sure, yeah, of course, of course. All right, so you guys okay with this? How we found all the sides and angles? We're cool with that? All right. So we're not going to do this page here. I'm going to kind of scratch the surface with the next packet, but just to read this so we kind of understand what we'll be doing eventually. This little experiment lab, or we'll actually take a little field trip outside and find some things to measure. But Faith, can you read the part about Statue of Liberty on 445? Yeah.
Lincoln gets notices whenever she is more than 300 feet above the ground. During a class field trip, her teacher asked if she wanted to climb to the top of the Statue of Liberty. Since she does not want to get a nosebleed, she decides to take some measurements. They got the height of the torch of the statue. She found a spot directly under the torch and then measured 42 feet away and determined that the angle up to the torch was 82 degrees. Her eyes are 5 feet above the ground. If she climbs to the top of the tower, will she get a nosebleed? Draw a diagram that fits the situation.
Okay. Actually, I didn't draw a situation as good as I could. Okay. Here we go. Okay, so that's 42. We'll call that's 82 degrees. Yeah. And we'll call this X. And by the way, this right here is 5. So actually we should do this one. This is a good problem to do. It's a good word problem. Do you guys see how I made that diagram? Right, the person's 5 feet tall. So the person's eyes are not at the base of the statue. It's a little bit higher, right? The distance between her eyes and the statue is 42 feet. And we need to solve for X. So if I solve for X, that should be pretty easy. Tan 82 degrees equals X over 42. Is that good? Yeah, of course, yeah. So X will be 42. So are you guys okay with the setup? Do you guys see how I set it up? Does that make sense? But you have to account for the person's height. So that's why I drew the horizontal leg a little bit higher above the ground and going like cutting off the Statue of Liberty's legs a little bit, right? I mean, of course, 5 feet's not that high, but we'll go with it. Solve for X. Should get 298. So it looks like she'll be okay. However, is that the true height of the Statue of Liberty?
Add 5.
You must add the 5. So if add 5, that's 303.85. So the answer is no. She should not. So it's a little tricky because you couldn't just assume X was a height. You had to add 5 afterwards. So just be mindful about that. I don't know. She's crazy. So who knows?
How did you get 298?
I used a calculator. I did 42 times 10^82. So, but the one thing that is tricky about this problem for a real life application, because we are actually going to do something like this, we'll actually go outside and measure the height of the main building, like the clock, the little bell tower. But the distance is easy. Just get some measuring tape, right? That's not hard to do. Like just go, you know, I got some at my house or we have some here. That's not hard to do. The angle, that's a little tricky. How do you do that? And we'll talk about that on the next page. Reagan? I'll talk on the next page. I'll show you how. Not probably this week, actually, and tomorrow is supposed to rain like crazy. It's Thursday, maybe Thursday if we could. If not, then next week. No, that'd be dangerous. That'd be a live. We're not climbing. Okay. Wherever you guys want to go. Go wherever you guys want. We could measure whatever you guys want. Right here. Now, what you do something called a clinometer that measures a slope angle and a meter six. So we'll use a tape measure. So we'll measure like, oh, well, I'm standing 30 feet away from the building or whatever. There's a little device, it's called a clinometer, where you actually, I think you have to look at through like through a lens or something. It's a weird kind of contraption, but there's a contraption you can use that can measure the angle from where you're standing to the top of something. So it finds a measure of elevation for you. But correct, yeah. Actually, I'll look it up right now. Here, what's the clinometer here? Clino.
For measuring.
Not tomorrow. Maybe Thursday. Yeah, clinometer looks like this.
Oh.
Yeah, it's kind of this contraption they use to
See that to measure?
yeah, you kind of like look through. I don't know. Yeah, here's a good example. Yeah, you see this man's like looking at, and then
To that.
I don't know. Good question. No idea. So anyhow, we'll worry about that later. Last thing I want to talk about is just the last part of the notes. Sorry, the thick notes. Oh, crazy. A lot of pages. Oh, by the way, these notes have all the filled out notes as well. So if you're missing class, or if you want to get like look ahead and see what the filled out notes look like, or just to check your notes, you should still write stuff down, by the way, because you want to work out problems. But if you work out problems and you're not sure if you got the examples right or wrong, these packets I gave you have all the fill out notes, just so you know. This seems bigger, I think. It's a lot, yeah. Yeah. Okay, last thing, actually, you know what? We ended what, 9 minutes? That's okay. We'll stop. We'll stop for today. Yeah, that's okay. You guys want to see pictures of Portugal? All right, let me pull up pictures of Portugal. Okay.
Just rent a.
Okay. I gotta see where I might have these pictures. Hold on. Let me figure out where I have them.
Same thing you're doing.
Yeah, correct. Here, I'll do a little search in Portugal.
But how do you find the variables if you don't know any of the sides?
Sorry, say again?
Like for this,
Mhm.
you can't do opposite over adjacent.
Yes, we're gonna learn a new trig function. That's why I don't want to start right now. Yeah.
Oh, yeah,
Hmm.
the hypotenuse.
Yeah, it's a new trig function called like sine and cosine.
Yeah. Where's it? It's in the- You, right here?
Yeah. Are you? What?
Like, I'm probably like this like that, because it's like an overnight one, I was like, oh, yeah, I'm dead. I don't. Wow. Mr. E, how did one download a PDF on the calculator?
What was that? Sorry?
Download PDF on the calculator.
I don't know.
That, in the
Get the OGs out of there.
For a friend, if I wanted to download, the answers to that test,
Sorry.
I would want to go back.
I have no idea. This is my phone.
And then he's so like.
I lost. Actually, no.
Wait, are you sure that's not?
Yeah, I'm uploading right now. So they're on my phone. I'm uploading right now.